All right, so here is lesson 5 of our fraction unit. And if you look at problem number 1, you see a chart, and we're supposed to fill in the chart and then whisper the fractional unit. So since we're on the video, we won't whisper it, but you can think it in your head. So let's look at part A. For each figure, we're supposed to write the total number of equal parts, the total number of parts that are shaded, and the unit form and the fraction. So if you look at this triangle, how many equal parts are there? 2. And how many are shaded? 1. So the unit form is when we write it in words, and we're going to write that the shaded part is 1/2. Remember, 2 pieces are called halves, and then we're going to write that fraction numerically, 1/2. So that's what we're doing for the rest of these shapes in number 1. So letter B has 3 equal parts. There's 1 shaded. So the unit form is 1/3 this time. We write that 1/3. And letter C, we have 1, 2, 3, 4. Be careful when you're counting the pieces. There's 1 shaded. So the unit form for that is 1/4. Notice how I'm spelling fourth and third, by the way. Sometimes people like to switch the I and the R and leave out the U here. So this becomes 1/4 or 1/4. How many pieces here? We have 1, 2, 3, 4, 5. 1 shaded. Oops. So that becomes 1/5 or 1/5. Here we have 1, 2, 3, 4, 5, 6 pieces with 1 shaded. So that's 1/6. And the last one, I'm going to count by 2, is 2, 4, 6, 8. Our pattern got goofed up at the end there. Sorry about that. 1 shaded. So that is 1/8. EIGHTH, or 1/8. Okay? So they're just kind of showing you how fractions work with one section shaded. That's what this number on the top, the numerator, is showing. We've got 1 of the total shaded. And the denominator, the number on the bottom, is how many total pieces. It's not shaded over unshaded. It's shaded over total. Okay? All right, so let's flip to the back. Oh, we don't want to go back to that. Here we go. All right. So number 2 says, Andre's mom baked his 2 favorite cakes for his birthday party. The cakes were the exact same size. Andre cut his first cake into 8 pieces for him and his 7 friends. Did Andre cut this cake into 8ths? Explain your answer. Well, if you look at this, there are 1, 2, 3, 4, 5, 6, 7, 8 pieces, but are these actually 8ths? And the answer to that would be no, because remember, with a fraction, you need equal pieces. These are definitely not equal, and when it's made on the computer like this, they should be able to make them equal if they want to. So we're going to say these are not 8ths because the pieces are not equal. Okay, you can see this first column of pieces is real skinny and this is a real fat section, so those all should be equal if they are going to be 8ths. Okay, so hopefully that makes sense. Let's go down to number 3 then. 2 of Andre's friends came late to his party. They decided they will all share the second cake. So this was the first cake. Here's the second cake. Slice the second cake so that he and his 9 friends, I'm going to circle that, can each get an equal amount. What fraction of the second cake will they each receive? So we need to use this information to figure out how many total pieces we need. He and his 9 friends means 9 plus 1, which is 10. So we need 10 pieces. So the easiest way to make 10 is to divide this in half. And then you're going to cut 5 pieces this way. So we're going to make 4 lines. Okay, so that'll give you 1, 2, 3, 4, 5 on the top and the bottom. So what fraction will each person receive? That means one person. So our answer here is 1 out of 10, 1/10. All right, last one. Andre thinks it's strange that 1/10 of the cake would be less than 1/8 of the cake, since 10 is bigger than 8. Explain why 1/10 of the cake is smaller than 1/8 of the cake. Well, this is kind of a long answer, but when you look at this cake was cut into 10 pieces, so each piece has to be smaller to fit the whole. Up here, the pieces can be bigger because it doesn't need as many pieces. So the pattern that you'll notice is that if you're using the same whole, the more pieces you cut, or the bigger that denominator gets, the smaller the piece actually is. So that's a relationship that's really important to remember when you get to the point where you're comparing fractions. And that's what this is doing. So we're going to say 1/10 means, the cake had 10 pieces. Those pieces would be smaller than if the cake were cut into 8 pieces. Okay? Alright, so go ahead and get started on your Lesson 5 homework and turn it in when you finish.